So today we are discussing the topic that is green chemistry and its 12 fundamental principles in this webinar sessions. So shall we start this session? That is coming to the chemistry, we all know that it is a world of chemical reactions. So when we think about the green chemistry, that is immediately in our mind we think about the nature. So green chemistry can be considered as an any eco-friendly or environmentally benign chemical synthesis. So Paul T. Anastas is considered as a father of green chemistry, and according to his view, green chemistry can be defined as any chemical reactions which, when carried out in teaching laboratories or industries, should create none or minimum byproducts that pollutes the atmosphere. So while designing a green chemical synthesis, we have to follow 12 fundamental principles. So let us look which are they. So first principle is the prevention of waste or minimum byproducts in a chemical reactions. Second is the atom economy. Third one is less use of hazardous chemical synthesis. Fourth one is designing of safer chemicals. And fifth one is use of safe solvents and auxiliaries. Sixth one is minimize the energy requirement for a chemical reactions. And seventh one is use of renewable feedstock. And eighth one is reduce the use of derivatives or protecting groups. And ninth one is use of catalyst in this reaction. And 10th one is whatever products we are designing, it should be degradable. That is for the 10th principle, design for degradation. And 11th principle is real-time analysis to prevent the pollution. And 12th one is reduce the risk of accidents in a chemical reactions. So let us discuss each principles in detail. So coming to the first principle, that is preventions of waste or minimize the byproducts in a chemical reactions. So this principle can be easily explained by taking a simple examples in our daily life. So suppose our room is or suppose our house is clean and tidy means there will be no effort to clean up that room or house. But if our room is too messy or too untidy means there should be have we should take an effort to clean up that room. Same concept we are using in this principle. That is, whenever we are carrying out the reaction or chemical reactions, we have to prevent the formations of waste or we have to prevent the formations of byproducts in a chemical reactions. But it is impossible to produce a zero waste in a chemical reactions. But whatever waste produced in one industrial process or one chemical reactions, we can use for other reactions. Thereby, we can minimize the discharge of this waste or byproducts discharging to the atmosphere. So, we all know that polystyrene, it is a fossil-based polymer and it is useful for making toys, plates, cups, etc. As well as it can be used as a packaging material. And for using polystyrene as a packaging material, we have to modify that polystyrene or we have to expand that polystyrene. So traditionally, we are using for the modifications of polystyrene by CFC. We all know that CFC, that is chlorofluorocarbon, is a harmful pollutant and as it depletes the ozone layer. So we have to find an alternate pathway to modify or expand the polystyrene. So nowadays, we found that carbon dioxide waste excreted or liberated from the various other industrial processes are used for the modifications of polystyrene. So if you are using carbon dioxide liberated from various other industrial processes to modify this polystyrene means excess liberations of carbon dioxide to the atmosphere can be prevented and thereby we can prevent the global warming in the atmosphere. So this way we can prevent the formations of waste or discharge of waste or minimize the byproducts in the discharging to the atmosphere. If large amount of waste or large amount of byproducts are discharging to the atmosphere means it will increase the cost to clean up the environment. So that is all about the first principle. Coming to the second principle, that is atom economy. So coming to the second principle, that is atom economy. The term atom economy was first introduced by B.M. Trost, and it can be found out by dividing the molecular weight of desired product divided by summation of the molecular weight of the reactants into 100. So while designing a chemical reactions, it is necessary to find out the atom economy of the reactions. If our reactions is 100% means it is completely green. So consider a technique, that is consider a simple example, that is preparing a cake. When you're preparing a cake, you have to add flour, you have to add eggs, baking powder, baking soda, and whatever flavor you are adding, you can add, and then you are adding some decorating. And for decorations, you are adding cherry, nuts, etc. for the preparations of cake. But when the cake is forming, we found that only there is no more reactant left unreacted. We are getting only cake as the ultimate product. So same thing only when we are designing any chemical reactions, maximum reactant should be incorporated in the formations of the product. So consider the synthesis of an ibuprofen. Ibuprofen was normally used as a painkiller, and traditionally this ibuprofen was synthesized by a six-step synthesis. And when we calculate the atom economy, it is found that only it is about 40%. That is, we are getting the ibuprofen molecular weight as 206.29, and we are taking the molecular mass of all the reactant participated in that reactions and adding, we are getting 515 515, and then on dividing we are getting a percentage of atom economy as 40%. That means around 60% of the reactant are left unreacted. That means it is not considered as green because more than half are left unreacted. That means it is not considered as a 100% atom economical reactions. So we have to find an alternate pathway for the preparations of an ibuprofen. So nowadays we are preparing the ibuprofen by a three-step synthesis. And when we looked at percentage of atom economy of these reactions, we found that it is around 77%. So 77% percentage means only 23% of the reactant are left unreacted. And moreover, when we looked at reactions, each step of the reactions, we found that in some step, that is second step, we are using a catalyst, that is Rani nickel. And third step, we are using another catalyst, that is palladium. And after the reactions, we can, one of the advantages of using the catalyst is that we can reuse that catalyst after carrying out the reactions. So these reactions is found to be atom economical reactions. Again, in chemistry, when we are discussing, there are four type of reactions. One it is rearrangement reactions, next is the addition reactions, and the third one is the substitution reactions, and fourth one is the elimination reactions. So we can consider which reactions is which all reactions can be 100% atom economical reactions. So consider the reaction that is rearrangement reactions. First, we are taking an example, that is it is an ortho allyl phenyl ether. In this case, when this allyl phenyl ether is heated to 200 degrees Celsius, we found that there is a simple rearrangement in this reaction. That means there is no more byproduct is formed. Simple rearrangement inside that molecule. So when we are calculating the atom economy, we are getting 100%. So the rearrangement reactions can be considered as an 100% atom economical reactions, or it can be considered as a green reactions. To the next reaction, that is addition reactions. So when certain reagents are added to a double bond or triple bond, actually the addition reactions is carried out by the compound containing double bond or a triple bond. So when certain reagents are added to the compound containing double bond or triple bond, all the reagent or all the reactant get added to that compound. That means there is no more byproduct present in these reactions. So when we calculate the atom economy, also here we are getting 100% atom economy. So that means addition reactions, whatever addition reactions carrying out also, it can be considered as a green reactions. To the third reaction, that is substitution reactions. Substitution reactions, by the name itself, we can understood that one group of atom is replaced by another group of atom, or one atom is replaced by another. So obviously there will be some byproduct in that reactions. So consider this reactions, it is an ester, and it on reactions with methylamine, we are getting an amide. That is, there is a liberations of ethyl alcohol. So when we calculate the atom economy, it is found to be around only 65.40. So there is obviously there are some reactant which are left unreacted in the formations of the product. So the substitution reactions cannot be considered as an 100% atom economical reactions. In considering the last reaction, that is elimination reactions. Elimination reaction also, by the term itself, we can understood that some group of atom are eliminated, thereby it exists as a byproduct in the reactions. So the elimination reactions can also be cannot be considered as an 100% atom economical reactions. So whenever we are designing a chemical reactions, there should be maximum cooperations of the reactant in the formations of the product. That is the second principle, that is atom economy. The third principle, that is less use of hazardous chemical synthesis. So think about a raw material, that is think about the product, whatever we are using in the day-to-day life. One thing that is what we are using, all we are using, it is clothes. And this clothes, when you are thinking, it is made up of some polymer, that is nylon. Again, when we think about paints, paint also it is necessary for the day-to-day life because all houses are painted. So again, paints are prepared by another polymer, that is polyurethane. Consider the window panel, and window panel is made up of PVC. So all these polymer require a typical acid, that is adipic acid. And traditionally, this adipic acid is synthesized by the use of benzene as a solvent. And we all know that this benzene is highly carcinogen in nature. So when we are preparing this adipic acid, there is a requirement of the solvent, that is benzene, and which is highly carcinogenic. So those who are preparing this adipic acid, that workers should have an extreme care. That is, it all increases the cost of productions, or it all increases the cost, and thereby workers also should have some safety, have to take some safety measures. So we have to find again a green pathway to prepare the adipic acid. So nowadays, these adipic acid are prepared by using the solvent glucose. And we all know that glucose is a simple sugar and it is produced from a genetically modified bacteria and it is less harmful to the environment. So in the principle 3, it conveys that whatever chemical we are preparing, that is whenever we are designing a chemical synthesis, we should use a less hazardous reactant for the formations of that chemical. That is the principle number 3. So coming to the fourth principle, that is the designing of safer chemicals. That is, in this principle, we are telling that whenever we are producing or we are synthesizing any chemical, it should be designed. That means it should be designed to save to use. So in industries, we all know that chemists are trying to synthesize compounds that are chiral. This chiral molecule means it has a particular shape and it prevents the unwanted side effect. And thereby we can use it, and thereby it is less harmful to the environment. Again, when we consider the medicine field, also almost all drugs are 100% of drugs are found to be chiral. And by understanding the correct chirality of that compound, we can safely target that compound to the specified organs and thereby we can prevent the side effect of that chemicals. So that is, so in the principle number 4, we tells that whatever chemicals we are synthesizing, it should be safe to use. And A typical example of unsafe drug is thalidomide. This thalidomide is actually used as a uh, um, medicine to treat the morning sickness for the pregnant woman. So consuming this medicine, this by the pregnant woman, we found that the child gave birth to that woman as having a birth defect. And by research studies, it shows that because of this thalidomide, the children is born with a both birth defect. So again, wide research shows that this thalidomide has a tendency to change from cis to trans. Actually, the correct chirality is cis thalidomide, and this cis thalidomide is safe to use. But by storing that chemical, by the wrong storage of that chemical, it has a tendency to change into another chirality, that is trans chirality, and thereby it produces side effect. So, whenever that is why this principle number 4 conveys that whenever we are designing the chemicals, we have to understand the correct chirality of the compound, and we have to understand the safe storage of that chemical also. Coming to the next principle, that is principle number 5, that is use of safer solvent and auxiliaries. So most of the chemical reactions need a solvent medium. And when we are using solvent, we will use either water, or more commonly, we cannot use water in every chemical reactions. We are using organic solvents and the chemical reactions. And when we consider these organic solvents like benzene or acetone or ethyl alcohol, etc., it has a tendency to vaporize. That means they are highly volatile. So volatile means it will lead to some harmful to the environment, because continuously vaporizing that chemicals means it will cause a serious damage to the environment as well as the human beings. So whenever we are designing a chemical reactions, we have to carry out the reactions in a solventless medium, or maximum in an aqueous medium, or we can use a safer solvents like supercritical carbon dioxide or ionic liquid, etc. And one important advantages of these solvents are it maintains the solvency of the material, and moreover it will not volatile. They are not volatile, and it will not cause any harmful to the environment. So that is conveyed in the principle number 5. In traditionally, we found that the dry cleaning of the cloth was done using the solvent, that is tetrachloroethene. So whenever we look a halogenated containing organic compound, it is highly carcinogen in nature, and moreover, when it is discharging to the environment, when this chemical is discharging to the environment, it contaminates the groundwater. So we have to find an alternate pathway for the dry cleaning the cloth. So nowadays, this dry cleaning of cloth is done by using liquefied carbon dioxide. And replacement of this halogenated by liquefied carbon dioxide shows that this liquid carbon dioxide, when it is discharging to the atmosphere, it will not harm the groundwater, and moreover, it is not carcinogenic in nature. So we have to find a solvent that whenever we are designing a chemical reactions, we have to find a better solvent, that is which will not produce any harmful to the atmosphere as well as to the human beings. So coming to the next principle, that is principle number 6, that is design for energy efficiency. That means whenever we are carrying out the chemical reactions, we have to minimize the energy requirement for the reactions. So that means if the reactions require large amount of a heat, means it increases the cost of reactions, and thereby increases the energy of the reactions. So whenever we are carrying out the reactions, we have to try the reactions at ambient temperature and pressure. And we found that in 2005, a group of chemists has awarded Nobel Prize for carrying out the reactions at ambient temperature and pressure and using an energy efficient catalyst. So, that type of reactions is termed as metathesis reactions, and by these metathesis reactions, we can introduce so many, we can prepare so many chemicals such as herbicides or whatever drugs we can prepare by this metathesis reactions. Thereby, we can minimize the energy requirement for the reactions since the reactions are carried out at ambient temperature and pressure, and moreover, we are using an energy efficient catalyst. So, principle number 6 conveys that whenever we are designing a chemical reactions, unnecessary heating and heating for a long time we have to avoid, and so that we can minimize the energy requirement for a chemical reactions. Then only we can consider that reactions as a green. So consider the principle number 7, that is use of renewable feedstock. We know that crude oil. Crude oil is a non-renewable resources and it is obtained. It takes billions of years to deposit in layers of sediments, so that it is it is very harmful to the environment also. So whenever we are designing a chemical, we have to find that starting material from a renewable feedstock, because renewable feedstocks are obtained from the natural resources. So we all know that printable inks. Printer inks are actually made up of crude oil in traditional way, and this so that paper cannot be recycled easily, because if paper has to be recycled, first the printer ink has to be removed. If the printer ink is printed with the crude oil, means it is difficult to remove from that paper, so that the paper cannot be recycled easily, cannot be recycled, so it is harmful to the environment. So it is considered as a waste and it is harmful to the environment. So nowadays we have found that soy based inks are there, and which is made up of a soybean based plant, and so that by using this ink, the paper can be recycled easily, because this ink can be removed from the paper easily. So the principle number 7 conveys that whatever chemicals we are introducing, whatever products we are introducing in the world, means we have to find from the renewable, that is, we have to find the starting material from a renewable feedstock, that is, renewable resources. So coming to the next principle, that is principle number 8, that is reduce the derivative. We all know that functional group is a one. If there is a functional group, it is the reactive site for the chemical reactions. And suppose in our compound, if there are so many functional group, means we have, and if we want to carry out the reactions at one particular point, means we have to block other functional group, uh, and we have to start the reactions. That means that type of reaction is termed as an blocking groups or protecting groups. That means first, if the compound contains, suppose if the compound contains a double bond and an aldehyde, and if we want to reduce only aldehyde, means, and if you are using reducing agents such as hydrogen in the presence of palladium or nickel, we found that this hydrogen in the presence of palladium or nickel can reduce both double bond and aldehyde. So we cannot reduce one functional group at a time. But nowadays we found that there are some chemoselective reagent which can reduce a particular functional group or particular point they can reduce. So suppose if you are using sodium borohydride in these reactions to reduce, that is, it can reduce only aldehyde, but it cannot reduce double bond. And if we are using protecting group, means that is, we have to first, if we are protecting, and then we are doing the reactions, and the next step is to deprotect that protecting groups, and that all increases the cost of reactions, and thereby it increases the large use of chemicals. So atom economy also tends to decrease. So that is why principle 8 conveys that whenever we are designing a chemical synthesis, if there are so many functional group also, we have to understand the reduction, understand the particular reagent chemoselectivity, and then we have to find out the reactions rather than the protections and deprotection reactions. So next principle is principle number 9, that is use of catalyst. That is, whenever we are carrying out the reactions, we have to use catalyst. We can use catalyst, and by the use of catalyst we can increase the speed of reactions, and thereby we can reduce the energy requirement for the reactions. And another important advantages of using catalyst in a chemical reaction is that we can reuse that catalyst after the reactions is done. So by purifying the catalyst, we can reuse the catalyst. That is why whenever a chemical synthesis is carrying out, if there is a need of any catalyst, means we can use a biological catalyst. And again, more large number of toxic metal catalysts are available. Again, use of that catalyst will uh, produce harmful to the atmosphere. Beside the use of toxic metals as a catalyst, we find an alternate pathway by using a biological catalyst like enzymes, etc. So that by using enzymes or as a catalyst, we can increase the speed of the reactions, and thereby we can minimize the energy and cost of production. So next principle, coming to the next principle number 10, that is design for degradations. So this principle conveys that whatever products we are designed, it should be biodegradable. So suppose if the waste is produced in large amount, means it cannot be easily broken down by the microbes, and thereby it produces very harmful threat to the environment. So nowadays, we found that plastic, usually when we consider the plastic, means it is not biodegradable. But nowadays, new type of plastics are available, that is termed as a bioplastic, and it is made from polyglycolic acid and lactic acid. So after we are throwing to the environment or discharging to the environment, it will degrade it will be broken down by the microbes, and thereby it will not produce any harmful threat to the environment. Similarly, during the operation time, we are uh, stitching the wound by some polymers. That is usually traditionally we are done with the nylon. But this nylon, it is harmful to degrade. That is, it is harmful to broken down by the microbes or by the enzyme present in our body. So it will produce a serious threat for the humans. So nowadays, a new type of polymer has introduced, that is polyglycolic acid. So after stitching the wound, there is no need to taken out from the body, because it will slowly degrade and it will slowly broken down by the enzyme present in our body, and the harmful product can be excreted through the urine. So that is why whenever we are designing any product, there should be a chance to degrade. That is, it should be biodegradable. So coming to the next principle, that is principle number 11, that is real-time analysis for pollution preventions. So whenever we are carrying out the reactions, before going to the large scale, first we have to take on the same reactions in a small scale. So if you are carrying out in the small scale, we can monitor that reactions. That means how much time it is required and what all pollutants are producing in the small scale. We can monitor entire thing, and then we should carry out the reactions in the bulk scale, so that we can prevent the harmful byproducts discharging to the atmosphere. That is the conveyed in the principle number 11. Coming to the last principle, that is principle number 12, that is reduce the risk of accident. We know that certain chemicals require the use of manufacturing plant. For example, that is methyl isocyanate. Usually, methyl isocyanate is prepared in a manufacturing plant, and by the leakage of this manufacturing plant, it lead to the loss of thousands of lives of people. And in Bhopal, and that is termed as Bhopal gas tragedy, and occurred in 1984. Or it is at so whenever we are carrying out a chemical react, and whenever we require a manufacturing plant, we have to design, we have to understand what all hazards it has posed by the toxicity, explosions, fire, etc. We have to understand about the manufacturing plant clearly, and so that we can reduce the risk of accidents during their operations. So that is the principle that is a fundamental principle involved in the principle number 12, that is reduce the risk of accident during the operations. So these are the 12 fundamental principles. So we found that green chemistry is not a solution for all environmental problems, but whenever we are designing a chemical synthesis, we have to keep in our mind these fundamental principles so that we can prevent the pollutions.